Picture this: a massive asteroid, hurtling silently through the void of space, is on a collision course with Earth. But before panic can set in, a network of advanced satellites detects the threat years in advance. Scientists, armed with cutting-edge technology, calculate its trajectory with pinpoint accuracy and devise a plan to deflect it. The asteroid is safely redirected, and life on Earth continues uninterrupted. This isn't science fiction, it's the future of space-based disaster prediction. Welcome to a world where technology doesn't just react to disasters, but anticipates and prevents them. In this video, we'll explore 30 groundbreaking predictions about how space-based systems will revolutionize our ability to predict, prepare for, and even prevent disasters. From earthquakes and tsunamis to solar storms and pandemics, the future of disaster prediction is being written in the stars. Stay with us as we uncover how these advancements will not only save lives but reshape our relationship with the planet and the cosmos. The future is closer than you think. Let's dive in. Now, let's take a closer look at the first prediction: artificial intelligence-powered satellite networks. Imagine a vast web of satellites orbiting Earth, constantly scanning the planet's surface, oceans, and atmosphere. These aren't just ordinary satellites, they're equipped with advanced artificial intelligence systems that can process data in real time. These AI-driven constellations will act as Earth's early warning system, detecting subtle changes that could signal the onset of natural disasters like earthquakes, tsunamis, and volcanic eruptions. Here's how it works. These satellites will collect massive amounts of data, everything from ground vibrations and ocean wave patterns to gas emissions from volcanoes. But raw data alone isn't enough. That's where machine learning algorithms come in. These algorithms will sift through the data, identifying patterns and anomalies that human analysts might miss. Over time, as the system learns from past events, its predictions will become more accurate, giving us unprecedented foresight into potential disasters. For example, in the case of earthquakes, these satellites could detect tiny shifts in the Earth's crust long before a major quake occurs. Similarly, for tsunamis, they could monitor changes in ocean height and wave patterns, providing early warnings to coastal communities. And when it comes to volcanic eruptions, they could track gas emissions and ground deformation, predicting eruptions weeks or even months in advance. The beauty of this system lies in its ability to operate continuously and autonomously. Unlike traditional methods that rely on ground-based sensors and human analysis, these AI-powered satellites can monitor the entire planet simultaneously, providing real-time updates and predictions. This means faster response times, more accurate forecasts, and ultimately, more lives saved. As we move forward, the integration of artificial intelligence into satellite networks will not only enhance our ability to predict disasters, but also transform how we prepare for and respond to them. It's a game changer in the world of disaster prediction, and it's just the beginning of what's possible when we combine the power of space technology with the intelligence of machines. Next, we'll explore how quantum computing will take disaster prediction to an entirely new level, enabling scientists to simulate and predict disasters with extreme precision. Stay tuned. Now, let's shift our focus to the next groundbreaking prediction: quantum computing for disaster modeling. Picture this: traditional computers, as powerful as they are, often struggle to process the immense complexity of climate and geological models. These models require analyzing countless variables, from atmospheric pressure and ocean currents to tectonic plate movements. But quantum computers, they're in a league of their own. Quantum computers operate on principles that allow them to perform calculations at speeds unimaginable with today's technology. Instead of relying on binary bits, which can only be in a state of 0 or 1, quantum computers use qubits. These qubits can exist in multiple states simultaneously, enabling them to process vast amounts of data in parallel. This means they can tackle problems that would take traditional computers years to solve in mere seconds. So, how does this apply to disaster prediction? Imagine being able to simulate the Earth's climate system with extreme precision, accounting for every possible variable. Quantum computers could analyze decades of climate data in moments, identifying patterns and trends that could signal future disasters. For example, they could predict the likelihood of extreme weather events such as hurricanes or droughts with unprecedented accuracy. But it doesn't stop there. Quantum computing could also revolutionize our understanding of geological processes. By simulating the movement of tectonic plates in real time, scientists could predict earthquakes with a level of detail never before possible. These simulations could even account for subtle changes in the Earth's crust, providing early warnings for volcanic eruptions or landslides. The implications are staggering. With quantum computing, we're not just improving our ability to predict disasters, we're fundamentally changing how we understand the Earth's systems. This technology could give us the tools to anticipate disasters years in advance, allowing governments and communities to prepare like never before. As we look to the future, the integration of quantum computing into disaster modeling promises to unlock new frontiers in science and technology. It's a leap forward that could save countless lives and reshape our relationship with the planet. Next, we'll dive into the world of space-based weather stations and how they'll provide hyper-accurate forecasts for severe weather events. Stay with us as we explore this fascinating development. Now, let's turn our attention to the skies above, where the future of weather prediction is taking shape. Imagine a network of advanced weather stations orbiting the Earth, constantly monitoring our planet's atmosphere with unparalleled precision. These space-based weather stations are set to revolutionize how we predict and respond to severe weather events, from hurricanes to tornadoes and beyond. Unlike traditional ground-based weather stations, which are limited by their fixed locations and coverage gaps, space-based systems offer a truly global perspective. Equipped with cutting-edge sensors and imaging technology, these orbiting stations can track atmospheric conditions in real time, capturing data from every corner of the planet. This means no storm, no matter how remote, will go unnoticed. One of the most exciting capabilities of these stations is their ability to provide hyper-accurate forecasts. By analyzing patterns in wind speed, temperature, humidity, and pressure, they can predict the formation and trajectory of hurricanes with incredible detail. Imagine knowing days in advance exactly where a hurricane will make landfall, down to the nearest mile. This level of precision could save countless lives by giving communities more time to prepare and evacuate if necessary. But hurricanes are just the beginning. These space-based systems will also excel at detecting the early signs of tornado formation. By monitoring subtle changes in atmospheric instability, they can issue warnings minutes or even hours before a tornado touches down. For regions prone to these devastating storms, this could mean the difference between life and death. And let's not forget about other severe weather events like blizzards, heat waves, and monsoons. Space-based weather stations will provide continuous, high-resolution data that can help predict these events with unprecedented accuracy. Farmers, for example, could receive early warnings about droughts or heavy rains, allowing them to adjust their planting and harvesting schedules to protect their crops. Cities could prepare for extreme heat waves by activating cooling centers and distributing resources to vulnerable populations. The deployment of these advanced weather stations marks a new era in meteorology, one where we're no longer just reacting to the weather, but anticipating it with confidence. By harnessing the power of space technology, we're not only improving our ability to predict disasters, but also empowering communities to take proactive steps to protect themselves. As we continue to explore the future of space-based disaster prediction, our next stop will take us even further into the cosmos. we'll examine how asteroid impact prediction systems are being developed to safeguard our planet from potential threats. Stay tuned as we uncover how humanity is preparing to defend itself against the unknown. Now, let's shift our gaze beyond Earth's atmosphere to a threat that has loomed over humanity for millennia: asteroids. While space-based weather stations are transforming how we predict storms, another groundbreaking system is being developed to protect us from cosmic dangers: asteroid impact prediction systems. These systems combine the power of space-based telescopes with advanced artificial intelligence to detect and track near-Earth objects, giving us the ability to foresee potential asteroid impacts decades before they occur. Picture this: a network of powerful telescopes stationed in orbit, scanning the skies day and night. These telescopes are equipped with state-of-the-art sensors capable of detecting even the faintest glimmers of light reflected off distant asteroids. But detecting these objects is only the first step. The real magic happens when artificial intelligence steps in. By analyzing the vast amounts of data collected, AI algorithms can calculate the trajectory, speed, and size of these asteroids with remarkable precision. This allows scientists to predict whether an asteroid poses a threat to Earth, and if so, when and where it might strike. What makes this system truly revolutionary is its ability to provide early warnings, sometimes decades in advance. Imagine knowing about a potential asteroid impact years before it happens. This kind of foresight gives humanity the time needed to develop and implement mitigation strategies. For smaller asteroids, deflection missions could be launched to nudge the object off its collision course. For larger threats, international cooperation could lead to the development of advanced technologies, such as kinetic impactors or even nuclear devices, to neutralize the danger before it reaches us. But the benefits of asteroid impact prediction systems go beyond just avoiding catastrophe. By tracking near-Earth objects, scientists can also gain valuable insights into the composition and behavior of asteroids. This knowledge could pave the way for future space exploration, including asteroid mining missions that could unlock untapped resources for humanity. As we continue to refine these systems, the dream of a world safe from asteroid impacts is becoming a reality. By combining the power of space-based telescopes with cutting-edge artificial intelligence, we're not just predicting disasters, we're actively working to prevent them. And with each new discovery, we're taking one more step toward securing our future in the cosmos. Next, we'll dive into another critical aspect of space-based disaster prediction: the development of a global earthquake early warning network. Stay with us as we explore how satellites are helping to save lives by detecting seismic activity before it strikes. Now, let's turn our attention to a technology that could redefine how we respond to one of Earth's most devastating natural disasters: earthquakes. While asteroid impact prediction systems are safeguarding us from cosmic threats, another groundbreaking innovation is taking shape closer to home: the Global Earthquake Early Warning Network. This system leverages space-based sensors to detect seismic activity, providing life-saving alerts before the ground even begins to shake. Imagine a network of satellites orbiting Earth, equipped with highly sensitive instruments designed to monitor the planet's crust. These sensors can detect the subtle shifts and vibrations that occur deep beneath the surface, often long before they manifest as destructive earthquakes. By analyzing this data in real time, scientists can identify patterns that signal an impending quake, giving communities critical seconds or even minutes to prepare. The key to this system lies in its ability to provide early warnings. When seismic activity is detected, alerts can be sent to smartphones, emergency services, and infrastructure systems, triggering automated responses. Elevators could stop at the nearest floor, gas lines could shut off to prevent fires, and people could take cover in safe zones. These precious moments can mean the difference between life and death, especially in densely populated areas. But the benefits of a global earthquake early warning network extend beyond immediate safety. By continuously monitoring seismic activity, scientists can also improve their understanding of earthquake behavior. This data can help identify high-risk zones, inform building codes, and guide urban planning to create more resilient cities. Over time, this knowledge could lead to the development of advanced materials and construction techniques that better withstand seismic forces. What makes this system truly transformative is its global reach. Unlike ground-based sensors, which are limited by geography, space-based sensors can monitor the entire planet. This means even remote or underdeveloped regions, which often lack the infrastructure for traditional earthquake monitoring, can benefit from early warnings. It's a step toward a more equitable approach to disaster preparedness, ensuring that no community is left vulnerable. As we continue to refine this technology, the dream of a world where earthquakes no longer claim countless lives is becoming a reality. By combining the power of space-based sensors with cutting-edge data analysis, we're not just predicting disasters, we're empowering people to act before they strike. And with each new advancement, we're building a safer, more resilient future for everyone. Next, we'll explore how satellites are revolutionizing wildfire detection, giving us the tools to combat one of nature's most destructive forces. Stay with us as we uncover the future of space-based wildfire monitoring. Now, let's shift our focus to another critical application of space-based technology: wildfire monitoring. Wildfires are among the most destructive natural disasters, capable of consuming vast areas of land, destroying homes and threatening lives. But what if we could detect these fires before they spiral out of control? Enter space-based wildfire monitoring, a game-changing innovation that combines thermal imaging and artificial intelligence to spot wildfires in their earliest stages. Picture this: satellites orbiting high above Earth, equipped with advanced thermal imaging cameras. These cameras can detect heat signatures on the planet's surface, identifying even the smallest flames or smoldering embers. But it doesn't stop there. Artificial intelligence algorithms analyze this thermal data in real time, distinguishing between natural heat sources and potential wildfires. This means that within minutes of a fire igniting, alerts can be sent to firefighting teams, enabling them to respond before the flames spread. The real power of this system lies in its speed and precision. Traditional methods of wildfire detection often rely on ground reports or aerial surveys, which can take hours or even days. By the time a fire is spotted, it may already be too large to contain. Space-based monitoring, on the other hand, provides near-instantaneous detection, giving responders a critical head start. This early warning can make all the difference, allowing firefighters to contain the blaze before it grows into a catastrophic event. But the benefits don't end there. Satellites can also monitor the progression of wildfires in real time, providing valuable data to firefighting teams. This includes information on wind patterns, fuel sources, and fire intensity, helping responders strategize their efforts more effectively. Additionally, the data collected can be used to create predictive models, identifying areas at high risk of wildfires and enabling proactive measures like controlled burns or vegetation management. One of the most exciting aspects of space-based wildfire monitoring is its global reach. Whether it's a remote forest in Siberia or a densely populated region in California, satellites can provide the same level of coverage and accuracy. This ensures that even the most isolated communities have access to life-saving early warnings, leveling the playing field when it comes to disaster preparedness. As we continue to refine this technology, the potential to save lives, protect ecosystems, and reduce economic losses is immense. By combining the power of space-based observation with artificial intelligence, we're not just detecting wildfires, we're preventing them from becoming disasters in the first place. And as we look to the future, this innovation could play a pivotal role in mitigating the growing threat of wildfires in a changing climate. Next, we'll dive into how space-based radar systems are transforming flood prediction, offering real-time insights that could save countless lives. Stay with us as we explore the future of flood monitoring from space. Now, let's turn our attention to another groundbreaking application of space-based technology: real-time flood prediction systems. Floods are among the most devastating natural disasters, often striking with little warning and leaving entire communities in chaos. But imagine a world where we could predict floods with pinpoint accuracy, giving people the time they need to evacuate and prepare. This is where space-based radar systems come into play, revolutionizing how we monitor and respond to flood risks. Picture satellites orbiting Earth, equipped with advanced radar systems capable of measuring river levels and rainfall patterns with incredible precision. These systems work by sending out radar signals that bounce off the Earth's surface, capturing detailed data about water levels, soil moisture, and even the speed of flowing rivers. This information is then processed in real time, allowing scientists to predict when and where floods are likely to occur. The key advantage of space-based flood prediction lies in its ability to provide continuous global coverage. Unlike ground-based sensors, which are limited to specific locations, satellites can monitor entire river basins and watersheds, offering a comprehensive view of potential flood risks. This means that even remote or underserved regions can benefit from early warnings, ensuring that no community is left unprepared. But the real game changer is the integration of artificial intelligence. By analyzing vast amounts of data from satellites, artificial intelligence algorithms can identify patterns and trends that might otherwise go unnoticed. For example, if a region experiences unusually heavy rainfall over several days, the system can predict the likelihood of river overflow and issue alerts before the water levels rise to dangerous levels. This early warning capability is crucial for enabling proactive evacuation plans, reducing the risk of casualties and property damage. Another exciting aspect of this technology is its ability to monitor multiple factors simultaneously. Satellites can track not only rainfall and river levels, but also soil saturation, snowmelt, and even the condition of dams and levees. This holistic approach allows for more accurate and reliable flood predictions, giving authorities the information they need to make informed decisions. For instance, if a dam is at risk of failure, emergency teams can take preemptive action to reinforce it or evacuate nearby residents. The impact of real-time flood prediction systems extends beyond immediate disaster response. The data collected by satellites can also be used to improve long-term flood management strategies. By identifying areas that are particularly vulnerable to flooding, governments and organizations can implement measures like improved drainage systems, flood barriers, or land use planning to reduce future risks. This proactive approach not only saves lives but also minimizes the economic and environmental toll of floods. As we look to the future, the potential of space-based flood prediction systems is immense. With advancements in satellite technology and artificial intelligence, we're moving closer to a world where floods no longer catch us off guard. By harnessing the power of space, we can protect communities, preserve ecosystems, and build a more resilient future. Next, we'll explore how satellites are transforming our ability to predict volcanic eruptions, offering insights that could save lives and prevent widespread destruction. Stay with us as we uncover the future of volcanic eruption forecasting from space. Now, let's shift our focus to another awe-inspiring application of space-based technology: volcanic eruption forecasting. Volcanoes, with their immense power and unpredictability, have long posed a significant threat to communities living in their shadows. But what if we could predict volcanic eruptions weeks or even months before they happen? Thanks to satellites, this futuristic vision is becoming a reality. Satellites orbiting Earth are now equipped with advanced sensors capable of monitoring volcanic activity in ways that were once unimaginable. These sensors track critical indicators like gas emissions, ground deformation, and thermal changes, providing scientists with a comprehensive picture of a volcano's behavior. For instance, satellites can detect the release of sulfur dioxide, a key gas emitted by active volcanoes, which often signals an impending eruption. Similarly, by measuring subtle shifts in the Earth's surface, satellites can identify ground deformation, a telltale sign that magma is building up beneath the surface. The ability to monitor these changes from space offers a significant advantage over traditional ground-based methods. Satellites can observe multiple volcanoes simultaneously, even in remote or inaccessible regions, ensuring that no volcanic activity goes unnoticed. This global coverage is particularly crucial for monitoring volcanoes in developing countries, where resources for ground-based monitoring may be limited. By providing early warnings, satellites can help authorities evacuate at-risk populations and prepare for potential disasters. One of the most exciting aspects of this technology is its integration with artificial intelligence. By analyzing vast amounts of data collected by satellites, artificial intelligence algorithms can identify patterns and trends that might otherwise go unnoticed. For example, if a volcano begins to show signs of increased gas emissions and ground deformation, the system can predict the likelihood of an eruption and issue alerts well in advance. This early warning capability is a game changer, giving communities the time they need to prepare and potentially saving countless lives. But the benefits of space-based volcanic monitoring don't stop at eruption prediction. The data collected by satellites can also be used to improve our understanding of volcanic processes, helping scientists develop more accurate models and forecasts. For instance, by studying the behavior of different volcanoes over time, researchers can identify common precursors to eruptions, enabling more reliable predictions in the future. This knowledge can also inform long-term risk management strategies, such as land use planning and infrastructure development in volcanic regions. As we look ahead, the potential of space-based volcanic eruption forecasting is immense. With advancements in satellite technology and artificial intelligence, we're moving closer to a world where volcanic eruptions no longer catch us off guard. By harnessing the power of space, we can protect communities, preserve ecosystems, and build a more resilient future. Next, we'll explore how satellites are revolutionizing our ability to detect tsunamis, offering early warnings that could save coastal communities from devastation. Stay with us as we dive into the future of space-based tsunami detection. Now, let's turn our attention to the vast oceans and the silent but deadly threat that lurks beneath their surface: tsunamis. These massive waves, often triggered by underwater earthquakes or volcanic eruptions, can devastate coastal communities within minutes. But what if we could detect tsunamis before they even reach the shore? Thanks to space-based technology, this is no longer a distant dream but a rapidly advancing reality. Satellites equipped with advanced altimeters are now playing a crucial role in tsunami detection. These instruments measure the height of the ocean surface with incredible precision, detecting even the slightest changes that could indicate the formation of a tsunami. When an underwater earthquake occurs, it displaces a massive amount of water, creating a ripple effect that travels across the ocean. Satellite altimeters can pick up on these subtle changes in sea level, often just a few centimeters high, and relay this data back to Earth in real time. This early detection capability is a game changer for coastal communities. By analyzing the data from satellites, scientists can quickly determine the size, speed, and direction of a potential tsunami. This information is then used to issue early warnings, giving people in at-risk areas precious time to evacuate to higher ground. For example, during the Indian Ocean tsunami in 2004, the lack of a robust warning system led to catastrophic loss of life. Today, space-based tsunami detection systems are helping to prevent such tragedies by providing timely alerts that can save thousands of lives. One of the most remarkable aspects of this technology is its ability to monitor the entire globe. Unlike ground-based sensors, which are limited to specific regions, satellites can observe the world's oceans continuously, ensuring that no tsunami goes undetected. This global coverage is particularly vital for remote or underdeveloped coastal areas that may lack the infrastructure for traditional monitoring systems. With satellites, even the most isolated communities can benefit from early warnings. The integration of artificial intelligence further enhances the effectiveness of space-based tsunami detection. By analyzing historical data and real-time observations, artificial intelligence algorithms can predict the potential impact of a tsunami with greater accuracy. For instance, if a satellite detects a sudden rise in sea level near a tectonic plate boundary, the system can assess the likelihood of a tsunami and estimate its potential reach. This predictive capability allows authorities to make informed decisions about evacuations and emergency response efforts. Beyond detection, the data collected by satellites also contributes to our understanding of tsunamis and their underlying causes. By studying the patterns of ocean surface changes, scientists can gain insights into the behavior of underwater earthquakes and volcanic eruptions, improving our ability to forecast future events. This knowledge not only enhances early warning systems, but also informs long-term strategies for coastal planning and disaster preparedness. As we look to the future, the potential of space-based tsunami detection is immense. With advancements in satellite technology and artificial intelligence, we're moving closer to a world where tsunamis no longer catch us off guard. By harnessing the power of space, we can protect coastal communities, preserve ecosystems, and build a more resilient future. Next, we'll explore how satellites are transforming our ability to monitor climate change, providing critical data that could shape the future of our planet. Stay with us as we dive into the role of space-based technology in tracking global environmental shifts. Now, let's shift our gaze to the skies and the critical role they play in understanding one of the most pressing challenges of our time: climate change. Satellites orbiting our planet are becoming indispensable tools in monitoring the Earth's changing climate, offering a bird's-eye view of environmental shifts that could shape the future of our world. From melting ice caps to rising sea levels, these space-based observatories are providing the data we need to predict and prepare for long-term environmental disasters. One of the most significant contributions of satellites is their ability to track the melting of polar ice caps. Using advanced imaging technology, these satellites can measure the thickness and extent of ice sheets with remarkable precision. For instance, data collected over the past few decades has revealed alarming trends, such as the rapid loss of ice in Greenland and Antarctica. This melting not only contributes to rising sea levels, but also disrupts global weather patterns, making it a critical indicator of climate change. By continuously monitoring these changes, scientists can better predict how quickly sea levels will rise and which coastal regions are most at risk. Rising sea levels are another key focus of space-based climate monitoring. Satellites equipped with radar altimeters can measure the height of the ocean surface with millimeter accuracy, providing a clear picture of how sea levels are changing over time. This data is invaluable for understanding the long-term impacts of climate change, such as the inundation of low-lying islands and coastal cities. For example, satellite observations have shown that sea levels have risen by an average of 3 millimeters per year over the past 2 decades, a trend that is accelerating due to global warming. With this information, policymakers and urban planners can develop strategies to protect vulnerable communities and infrastructure. But satellites don't just track the symptoms of climate change, they also monitor its root causes. By measuring greenhouse gas concentrations in the atmosphere, such as carbon dioxide and methane, satellites provide critical insights into the drivers of global warming. For instance, the European Space Agency's Copernicus program uses satellites to map carbon dioxide emissions across the globe, identifying major sources of pollution and tracking their impact on the climate. This data is essential for holding nations accountable to their climate commitments and guiding efforts to reduce emissions. Another groundbreaking application of satellite technology is its ability to monitor deforestation and land use changes. By capturing high-resolution images of the Earth's surface, satellites can detect the loss of forests, which play a vital role in absorbing carbon dioxide from the atmosphere. For example, satellite data has revealed the alarming rate of deforestation in the Amazon rainforest, a critical carbon sink that is shrinking due to agricultural expansion and illegal logging. This information helps governments and conservation organizations take action to protect these vital ecosystems and mitigate their contribution to climate change. The integration of artificial intelligence further enhances the capabilities of space-based climate monitoring. By analyzing vast amounts of satellite data, artificial intelligence algorithms can identify patterns and trends that might otherwise go unnoticed. For instance, these systems can predict how changes in land use or ocean temperatures might influence future climate scenarios, providing valuable insights for long-term planning. This predictive capability is crucial for developing strategies to adapt to the impacts of climate change, such as shifting agricultural practices or relocating communities at risk of flooding. As we look to the future, the role of satellites in climate change monitoring will only grow more critical. With advancements in technology, we can expect even more precise and comprehensive data, enabling us to tackle this global challenge with greater confidence. From tracking melting ice caps to monitoring greenhouse gas emissions, space-based technology is providing the tools we need to understand and address the complexities of climate change. By harnessing the power of satellites, we can work toward a more sustainable and resilient future for our planet. Next, we'll delve into how space-based observatories are keeping an eye on the Sun, predicting solar storms that could disrupt life on Earth. Stay tuned as we explore the fascinating world of solar activity monitoring. Now, let's turn our attention to the Sun, our closest star, and the powerful forces it unleashes that could impact life on Earth. Solar storms, massive eruptions of energy from the Sun, have the potential to disrupt our power grids, communication systems, and even satellites in orbit. But thanks to space-based observatories, we're developing the ability to predict these events before they strike, giving us a fighting chance to prepare and protect our infrastructure. Solar storms occur when the Sun releases bursts of energy in the form of solar flares and coronal mass ejections. These events send charged particles hurtling toward Earth at incredible speeds, creating geomagnetic storms when they interact with our planet's magnetic field. While these storms can produce stunning auroras, they can also wreak havoc on our technology. For example, a powerful solar storm in 1989 caused a massive blackout in Quebec, Canada, leaving millions without power for hours. More recently, a near-miss solar storm in 2012 could have caused widespread damage if it had hit Earth directly. This is where space-based observatories come in. Satellites like NASA's Solar Dynamics Observatory and the European Space Agency's Solar Orbiter are equipped with advanced instruments that monitor the Sun's activity in real time. These observatories can detect the early signs of solar flares and coronal mass ejections, providing critical data that helps scientists predict when and where a solar storm might strike. By analyzing this data, researchers can issue warnings hours or even days in advance, giving utility companies and governments time to take protective measures. One of the key tools in solar storm prediction is the ability to measure the Sun's magnetic field. Solar flares and coronal mass ejections are often triggered by complex interactions within the Sun's magnetic environment. Space-based observatories can map these magnetic fields, identifying regions of high activity that are likely to produce storms. For instance, sunspots, dark, cooler areas on the Sun's surface are often hotspots for solar activity. By monitoring these regions, scientists can predict when a flare or ejection might occur and estimate its potential impact on Earth. Another critical aspect of solar storm prediction is tracking the speed and direction of coronal mass ejections as they travel through space. Satellites positioned between the Sun and Earth, such as the Deep Space Climate Observatory, can measure the speed and trajectory of these ejections, providing valuable information about when they might reach our planet. This data is combined with models of Earth's magnetic field to predict the intensity of the resulting geomagnetic storm. For example, if a coronal mass ejection is expected to hit Earth's magnetic field at a certain angle, scientists can estimate how severe the storm will be and which regions are most at risk. The integration of artificial intelligence is also revolutionizing solar storm prediction. By analyzing vast amounts of data from space-based observatories, artificial intelligence algorithms can identify patterns and correlations that might otherwise go unnoticed. For instance, these systems can predict how changes in the Sun's magnetic field might lead to future solar activity, providing early warnings for potential storms. This predictive capability is crucial for protecting critical infrastructure, such as power grids and communication networks, which are vulnerable to the effects of geomagnetic storms. Looking ahead, advancements in space-based technology will further enhance our ability to predict and mitigate the impacts of solar storms. New observatories with even more advanced instruments will provide higher resolution data, enabling more accurate predictions. Additionally, international collaborations will allow for a more comprehensive understanding of solar activity, ensuring that no region is left unprepared. By staying one step ahead of the Sun's unpredictable behavior, we can safeguard our technology and maintain the stability of our modern way of life. Next, we'll explore how satellites are helping us predict another critical environmental challenge, droughts, and how this technology is transforming agriculture and water management. Stay tuned as we uncover the future of space-based drought forecasting. Now, shifting our focus from the Sun's fiery storms to the challenges we face here on Earth, let's explore how space-based technology is revolutionizing our ability to predict and manage droughts. Droughts, prolonged periods of water scarcity, have devastating effects on agriculture, ecosystems, and communities worldwide. But with the help of satellites, we're gaining unprecedented insights into soil moisture and vegetation health, enabling us to predict droughts before they occur and take proactive measures to mitigate their impact. Satellites equipped with advanced sensors, such as those on NASA's Soil Moisture Active Passive mission and the European Space Agency's Sentinel missions, are capable of measuring soil moisture levels from space. These sensors use microwave technology to penetrate the Earth's surface, providing detailed data on how much water is stored in the soil. This information is crucial for understanding water availability in agricultural regions, as soil moisture directly affects crop growth and yield. By monitoring these levels over time, scientists can identify areas at risk of drought long before the effects become visible on the ground. In addition to soil moisture, satellites also track vegetation health using tools like the Normalized Difference Vegetation Index, or NDVI. This index measures the amount of green vegetation on the Earth's surface by analyzing the light reflected by plants. Healthy vegetation absorbs visible light and reflects near-infrared light, while stressed or dying plants reflect less near-infrared light. By continuously monitoring these changes, satellites can detect early signs of vegetation stress, which often precedes drought conditions. For example, if a region's vegetation begins to show signs of stress during a dry season, it could indicate an impending drought, allowing farmers and policymakers to take action before crops are lost. One of the most significant advantages of space-based drought forecasting is its ability to provide real-time global coverage. Unlike ground-based sensors, which are limited to specific locations, satellites can monitor vast areas, including remote and inaccessible regions. This global perspective is particularly valuable for tracking large-scale climate patterns, such as El Niño and La Niña, which influence drought conditions worldwide. By combining satellite data with climate models, scientists can predict how these patterns will affect water availability in different regions, helping governments and organizations prepare for potential droughts. Artificial intelligence is also playing a key role in enhancing drought prediction. By analyzing the massive amounts of data collected by satellites, artificial intelligence algorithms can identify patterns and trends that might otherwise go unnoticed. For instance, these systems can predict how changes in soil moisture and vegetation health might lead to future drought conditions, providing early warnings for at-risk areas. This predictive capability is especially valuable for agriculture, where timely information can help farmers make informed decisions about irrigation, crop selection, and planting schedules. Looking ahead, advancements in satellite technology will further improve our ability to predict and manage droughts. New missions with higher resolution sensors will provide even more detailed data on soil moisture and vegetation health, enabling more accurate forecasts. Additionally, international collaborations will allow for the sharing of data and resources, ensuring that no region is left unprepared. By leveraging the power of space-based technology, we can transform how we approach drought prediction, safeguarding food security and water resources for future generations. Next, we'll dive into how satellites are helping us track another critical environmental challenge: orbital debris and the innovative systems being developed to prevent collisions in space. Stay tuned as we uncover the future of space-based debris monitoring. Now, let's turn our attention from the challenges of Earth to the growing concern in the skies above orbital debris. As humanity continues to expand its presence in space, the amount of debris orbiting our planet has reached alarming levels. From defunct satellites to discarded rocket stages, this space junk poses a significant threat to active spacecraft and satellites. But thanks to space-based systems, we're developing innovative ways to track and predict collisions, ensuring the safety of our orbital infrastructure. Space-based systems equipped with advanced sensors and radar technology are now capable of monitoring the vast expanse of Earth's orbit. These systems can detect and track even the smallest pieces of debris, some as small as a marble, moving at incredible speeds. By continuously collecting data on the position, speed, and trajectory of these objects, scientists can predict potential collisions with remarkable accuracy. For example, if a piece of debris is on a collision course with a satellite, these systems can provide early warnings, allowing operators to adjust the satellite's orbit and avoid disaster. One of the key technologies driving this capability is artificial intelligence. By analyzing the massive amounts of data generated by space-based sensors, artificial intelligence algorithms can identify patterns and predict the future movements of debris. This predictive power is crucial for managing the growing congestion in Earth's orbit. For instance, artificial intelligence can calculate the likelihood of collisions days or even weeks in advance, giving satellite operators ample time to take preventive measures. This not only protects valuable assets but also reduces the risk of creating more debris from collisions. International collaboration is also playing a vital role in addressing the orbital debris challenge. Organizations like the European Space Agency and NASA are working together to share data and develop standardized tracking systems. This global effort ensures that no region is left vulnerable to the risks posed by space junk. By pooling resources and expertise, these organizations are creating a comprehensive network of space-based monitoring systems that can track debris across the entire planet. Looking ahead, advancements in technology will further enhance our ability to predict and prevent collisions. New missions with higher resolution sensors and more powerful artificial intelligence systems will provide even more precise data on debris movements. Additionally, initiatives to actively remove debris from orbit are being developed, offering a long-term solution to this growing problem. By combining predictive capabilities with active debris removal, we can ensure the sustainability of space for future generations. As we continue to explore the possibilities of space-based disaster prediction, the next frontier we'll examine is how satellites are helping us monitor and predict the emergence of pandemics. Stay tuned as we uncover the fascinating ways space technology is safeguarding global health. Now, shifting our focus from the skies above to the ecosystems below, let's explore how space-based technology is revolutionizing our ability to predict and prevent pandemics. While we often think of satellites as tools for weather forecasting or disaster monitoring, their role in safeguarding global health is becoming increasingly vital. By observing environmental changes from space, satellites can provide early warnings about conditions that may lead to the emergence of infectious diseases. One of the key ways satellites contribute to pandemic prediction is by monitoring deforestation. When large areas of forest are cleared, it disrupts ecosystems and brings humans into closer contact with wildlife. This increased interaction raises the risk of zoonotic diseases, those that jump from animals to humans. Satellites equipped with high-resolution imaging can track deforestation in real time, identifying regions where habitat destruction is creating hotspots for potential disease outbreaks. For example, if a satellite detects rapid deforestation in a tropical region, scientists can analyze the data to assess the risk of diseases like malaria or Ebola spreading to nearby communities. Another critical factor satellites monitor is wildlife migration patterns. As climate change alters habitats, animals are forced to move to new areas, sometimes bringing diseases with them. Satellites can track these movements by observing changes in vegetation, water sources, and animal behavior. By combining this data with ground-based observations, researchers can predict where and when wildlife might come into contact with human populations, potentially triggering a new outbreak. This early warning system allows health organizations to prepare and respond proactively, reducing the risk of a pandemic. Satellites also play a crucial role in monitoring environmental conditions that favor disease vectors such as mosquitoes. By tracking temperature, humidity, and rainfall patterns, satellites can predict where mosquito populations are likely to thrive. This information is invaluable for forecasting the spread of diseases like dengue fever or Zika virus. For instance, if a satellite detects unusually high rainfall in a region, it can alert health authorities to the likelihood of increased mosquito activity, enabling them to implement preventive measures like mosquito control programs. The integration of artificial intelligence further enhances the predictive power of these systems. By analyzing vast amounts of satellite data, artificial intelligence algorithms can identify patterns and correlations that might otherwise go unnoticed. For example, an algorithm might detect a link between deforestation, wildlife migration, and the emergence of a new virus. This kind of insight allows scientists to anticipate potential pandemics before they occur, giving the world a critical head start in containment efforts. As we look to the future, the potential for space-based pandemic prediction is immense. New satellite missions with even more advanced sensors and data analysis capabilities will provide unprecedented insights into the environmental factors that drive disease emergence. By combining this technology with global health initiatives, we can create a safer, more resilient world. Next, we'll dive into how space-based systems are helping us detect and predict landslides in real time, offering another layer of protection for vulnerable communities. Stay tuned as we uncover the next frontier in disaster prediction. Now, turning our attention to the ground beneath our feet, let's explore how space-based technology is transforming our ability to predict landslides in real time. Landslides are one of the most devastating natural disasters, often striking without warning and causing significant loss of life and property. But with the help of advanced satellites and artificial intelligence, we're entering an era where these catastrophic events can be anticipated before they happen. Satellites equipped with radar technology play a crucial role in detecting ground movement. These radar systems send signals to Earth's surface and measure the time it takes for the signals to bounce back. By analyzing these measurements, scientists can detect even the slightest shifts in the ground, often long before a landslide occurs. This is especially important in mountainous or hilly regions, where unstable terrain can lead to sudden and deadly collapses. For example, if a satellite detects gradual ground movement in a landslide-prone area, it can alert authorities to the potential danger, giving them time to evacuate residents and take preventive measures. Artificial intelligence takes this capability to the next level. By processing vast amounts of radar data, artificial intelligence algorithms can identify patterns and trends that indicate an increased risk of landslides. These algorithms can analyze factors like rainfall, soil composition, and historical landslide data to make highly accurate predictions. Imagine a scenario where heavy rainfall saturates the soil in a vulnerable region. An artificial intelligence system could analyze satellite data and predict the likelihood of a landslide, issuing warnings days or even weeks in advance. This kind of early warning system has the potential to save countless lives and reduce the economic impact of landslides. One of the most exciting aspects of this technology is its ability to monitor remote and inaccessible areas. Many landslide-prone regions are difficult to reach, making ground-based monitoring challenging. Satellites, however, can observe these areas from space, providing continuous and comprehensive coverage. This is particularly valuable in developing countries where resources for disaster prevention may be limited. By leveraging space-based technology, these regions can benefit from the same level of protection as more developed areas. As we look to the future, the integration of space-based radar and artificial intelligence will only become more sophisticated. New satellite missions with higher resolution sensors and faster data processing capabilities will enhance our ability to detect ground movement with even greater precision. Combined with global efforts to improve disaster preparedness, this technology offers a powerful tool for protecting vulnerable communities from the devastating effects of landslides. Next, we'll shift our focus to the skies once more, exploring how advanced satellites are revolutionizing hurricane tracking and prediction. Stay with us as we uncover how space-based technology is helping us stay one step ahead of these powerful storms. Now, let's turn our gaze to the vast oceans, where some of the most powerful and destructive storms on Earth are born. Hurricanes, with their ferocious winds and torrential rains, have long posed a significant threat to coastal communities. But thanks to advancements in space-based technology, we're entering a new era where hurricanes can be tracked and predicted with unprecedented precision. Advanced satellites orbiting Earth are equipped with state-of-the-art sensors that monitor hurricanes in real time. These sensors capture critical data such as wind speeds, atmospheric pressure, and sea surface temperatures, which are essential for understanding a hurricane's behavior. By continuously observing these storms from space, satellites provide a comprehensive view that ground-based systems simply cannot match. This real-time data allows meteorologists to track a hurricane's path and predict its intensity with remarkable accuracy, giving communities more time to prepare and evacuate if necessary. One of the key tools in this space-based arsenal is the use of infrared imaging. Satellites equipped with infrared cameras can peer through the dense clouds of a hurricane, revealing the storm's internal structure. This information is crucial for identifying the formation of an eye wall, which often signals a rapid intensification of the storm. By detecting these changes early, scientists can issue timely warnings, potentially saving lives and reducing the economic impact of these devastating events. Another groundbreaking feature of space-based hurricane tracking is the ability to monitor multiple storms simultaneously. During peak hurricane seasons, when several storms may be active at once, satellites can keep a watchful eye on each one, ensuring that no storm goes unnoticed. This global perspective is invaluable for coordinating international disaster response efforts, and ensuring that resources are allocated where they are needed most. Artificial intelligence also plays a pivotal role in enhancing hurricane prediction. By analyzing vast amounts of satellite data, artificial intelligence algorithms can identify patterns and trends that human forecasters might miss. These algorithms can predict how a hurricane will evolve, including potential changes in its path or intensity, with a level of accuracy that was once unimaginable. For example, if a hurricane is expected to strengthen rapidly before making landfall, artificial intelligence can provide early warnings, allowing emergency services to mobilize quickly and effectively. The integration of space-based technology and artificial intelligence is not just about predicting hurricanes, it's about empowering communities to respond more effectively. With more accurate forecasts, governments can implement targeted evacuation plans, reduce unnecessary disruptions, and allocate resources more efficiently. This technology is particularly vital for vulnerable regions where the impact of hurricanes can be catastrophic. As we look to the future, the capabilities of space-based hurricane tracking will only continue to improve. New satellite missions with enhanced sensors and faster data processing will provide even more detailed insights into these powerful storms. Combined with ongoing advancements in artificial intelligence, this technology promises to revolutionize our ability to predict and prepare for hurricanes, ultimately saving lives and protecting communities around the world. Next, we'll shift our focus to another atmospheric phenomenon that poses a significant threat: tornadoes. Stay with us as we explore how space-based technology is transforming our ability to predict these unpredictable and deadly storms. Now, let's turn our attention to one of nature's most unpredictable and destructive forces: tornadoes. These swirling columns of air can form in mere minutes, leaving devastation in their wake. But with the help of space-based technology, we're on the brink of a breakthrough in predicting these deadly storms before they even touch the ground. Satellites orbiting Earth are now equipped with advanced sensors capable of monitoring atmospheric conditions in real time. These sensors track key indicators of tornado formation, such as wind shear, temperature gradients, and moisture levels. By analyzing these factors, satellites can detect the early stages of severe weather systems that are likely to produce tornadoes. This data is then relayed to ground-based meteorologists who can issue warnings to at-risk communities well before the storm develops. One of the most significant advantages of space-based tornado prediction is the ability to observe large-scale weather patterns from above. Unlike ground-based radar, which has limited range, satellites provide a global perspective, capturing the interactions between different weather systems. This broader view allows scientists to identify the conditions that lead to tornado formation, even in remote or sparsely populated areas where traditional monitoring might be lacking. Artificial intelligence further enhances this capability by processing the vast amounts of data collected by satellites. Machine learning algorithms can identify subtle patterns and correlations that human forecasters might overlook. For example, artificial intelligence can predict how changes in atmospheric pressure or wind direction might trigger tornado formation, providing earlier and more accurate warnings. This technology is particularly crucial in regions prone to tornado outbreaks, where every second counts. Another groundbreaking application of space-based technology is the use of high-resolution imaging to track storm development. Satellites can capture detailed images of supercell thunderstorms, the primary producers of tornadoes. By monitoring the structure and movement of these storms, scientists can pinpoint the exact areas where tornadoes are most likely to form. This level of precision allows for targeted warnings, reducing the risk of false alarms and ensuring that communities take the necessary precautions. The integration of space-based data with ground-based observations creates a comprehensive early warning system. For instance, when satellites detect the conditions for tornado formation, ground-based radar can focus on the specific area, providing real-time updates on the storm's progression. This combined approach ensures that warnings are both timely and accurate, giving people more time to seek shelter and emergency services more time to prepare. Looking ahead, the future of space-based tornado prediction is incredibly promising. New satellite missions with enhanced sensors and faster data transmission will provide even more detailed insights into severe weather systems. Coupled with advancements in artificial intelligence, these technologies will revolutionize our ability to predict tornadoes, saving lives and reducing the destruction caused by these powerful storms. Next, we'll explore how space-based technology is being used to monitor another natural hazard, avalanches. Stay with us as we uncover the innovative ways satellites are helping to predict and prevent these deadly snowslides. Now, let's shift our focus to another natural phenomenon that poses a significant threat to mountainous regions: avalanches. These sudden, powerful snowslides can bury entire communities in seconds, making early detection and prediction absolutely critical. Thanks to space-based technology, we're making strides in monitoring snowpack conditions and predicting avalanches before they occur. Satellites equipped with advanced radar and optical imaging systems are revolutionizing how we track snow accumulation and stability. These tools allow scientists to monitor snowpack thickness, density, and temperature across vast mountainous areas. By analyzing this data, satellites can identify unstable snow layers that are prone to sliding, providing early warnings to at-risk regions. This is especially vital in remote areas where ground-based monitoring is challenging or impossible. One of the key advantages of space-based avalanche detection is the ability to observe large-scale snow conditions over time. Satellites can track changes in snowpack over weeks or even months, identifying patterns that indicate increasing instability. For example, repeated freeze-thaw cycles or heavy snowfall followed by rapid warming can weaken snow layers, creating the perfect conditions for an avalanche. By detecting these trends early, satellites enable authorities to issue warnings and implement safety measures, such as closing roads or evacuating vulnerable areas. Artificial intelligence plays a crucial role in this process by analyzing the massive amounts of data collected by satellites. Machine learning algorithms can identify subtle changes in snowpack conditions that might be missed by human observers. These algorithms can also predict how weather patterns, such as incoming storms or temperature fluctuations, might impact snow stability. This level of precision allows for more accurate and timely avalanche forecasts, giving communities the information they need to stay safe. Another innovative application of space-based technology is the use of high-resolution imaging to monitor avalanche-prone slopes. Satellites can capture detailed images of mountain terrain, identifying areas where snow is accumulating or where previous avalanches have occurred. This information helps scientists map high-risk zones and develop targeted monitoring strategies. For instance, if a satellite detects a significant buildup of snow on a steep slope, it can trigger ground-based sensors to focus on that area, providing real-time updates on snow conditions. The integration of space-based data with local observations creates a comprehensive avalanche prediction system. When satellites detect unstable snowpack conditions, ground teams can conduct on-site assessments to confirm the risk. This combined approach ensures that warnings are both accurate and actionable, reducing the likelihood of false alarms and ensuring that resources are directed where they're needed most. Looking ahead, the future of space-based avalanche detection is incredibly promising. New satellite missions with enhanced sensors and faster data transmission will provide even more detailed insights into snowpack conditions. Coupled with advancements in artificial intelligence, these technologies will revolutionize our ability to predict avalanches, saving lives and protecting communities in mountainous regions. Next, we'll explore how space-based technology is being used to predict another natural hazard: lightning strikes. Stay with us as we uncover how satellites are helping to reduce the risks associated with this powerful force of nature. Now let's turn our attention to another powerful force of nature: lightning. While lightning is a breathtaking display of nature's energy, it also poses significant risks, from sparking wildfires to damaging electrical grids. Space-based technology is stepping up to tackle this challenge, offering new ways to detect and predict lightning strikes with remarkable precision. Satellites equipped with advanced optical and electromagnetic sensors are at the forefront of this innovation. These sensors can detect the faint flashes of light and the electromagnetic pulses produced by lightning strikes, even from hundreds of miles above Earth. By continuously monitoring these signals, satellites can map lightning activity in real time, providing a global picture of where and when lightning is occurring. This data is invaluable for predicting where lightning might strike next, giving communities and industries the chance to prepare and mitigate risks. One of the most critical applications of space-based lightning prediction is in wildfire prevention. Lightning is a leading cause of wildfires, especially in remote or dry regions where a single strike can ignite a blaze that spreads rapidly. Satellites can identify areas with high lightning activity and assess the surrounding conditions, such as vegetation dryness and weather patterns. By combining this information, scientists can predict which lightning strikes are most likely to start fires, enabling early intervention. For example, firefighting teams can be deployed to high-risk areas before a fire even begins, or controlled burns can be conducted to reduce available fuel. Another major benefit of space-based lightning detection is its ability to protect electrical infrastructure. Lightning strikes can cause power outages, damage transformers, and disrupt communication networks. By predicting where lightning is likely to strike, utility companies can take proactive measures, such as temporarily shutting down vulnerable power lines or reinforcing infrastructure in high-risk areas. This not only prevents damage but also ensures a more reliable power supply for communities. Artificial intelligence plays a key role in enhancing the accuracy of lightning predictions. Machine learning algorithms analyze historical lightning data, weather patterns, and atmospheric conditions to identify trends and predict future strikes. These algorithms can even forecast the likelihood of lightning in specific areas hours or days in advance, providing a valuable tool for emergency planners and first responders. For instance, outdoor events or construction projects can be rescheduled to avoid periods of high lightning risk, reducing the potential for accidents. Looking ahead, the future of space-based lightning prediction is incredibly promising. New satellite missions with higher resolution sensors and faster data processing capabilities will provide even more detailed insights into lightning activity. These advancements will not only improve prediction accuracy, but also expand our understanding of how lightning interacts with Earth's atmosphere and climate. By harnessing this knowledge, we can develop better strategies to protect lives, property, and ecosystems from the dangers of lightning. Next, we'll dive into how space-based technology is helping us predict another extreme weather event: heatwaves. Stay tuned as we explore how satellites are keeping us one step ahead of rising temperatures. Now, let's shift our focus to another critical aspect of space-based disaster prediction: heatwaves. As global temperatures continue to rise, heat waves are becoming more frequent and intense, posing serious risks to human health, infrastructure, and ecosystems. Space-based technology is playing a vital role in helping us anticipate and prepare for these extreme heat events. Satellites equipped with thermal imaging sensors and advanced climate monitoring instruments are revolutionizing how we track temperature trends. These sensors can measure surface temperatures across vast regions, from urban centers to remote deserts, providing a comprehensive view of heat patterns. By analyzing this data, scientists can identify areas where temperatures are rising faster than average, signaling the potential for a heat wave. This early detection allows cities and communities to take proactive measures, such as issuing heat advisories, opening cooling centers, and ensuring vulnerable populations have access to resources. One of the most significant advantages of space-based heatwave forecasting is its ability to monitor urban heat islands. Cities, with their dense infrastructure and lack of green spaces, often experience higher temperatures than surrounding rural areas. Satellites can pinpoint these urban heat islands, helping city planners implement strategies to reduce their impact. For example, increasing green spaces, installing reflective roofing materials, and improving ventilation can all help lower temperatures and make cities more resilient to heat waves. Beyond urban areas, satellites also play a crucial role in predicting heat waves in agricultural regions. Extreme heat can devastate crops, leading to food shortages and economic losses. By monitoring soil, moisture, and vegetation health from space, scientists can predict how heat waves will affect farming areas. This information allows farmers to adjust irrigation schedules, plant heat-resistant crops, or take other measures to protect their livelihoods. In turn, this helps stabilize food supplies and reduce the economic impact of extreme heat. Artificial intelligence is another game-changer in space-based heatwave prediction. Machine learning algorithms analyze historical temperature data, weather patterns, and atmospheric conditions to forecast heat waves with remarkable accuracy. These predictions can be made days or even weeks in advance, giving governments and organizations ample time to prepare. For instance, energy companies can anticipate increased demand for electricity during a heat wave and ensure power grids are ready to handle the load, preventing blackouts. Looking ahead, the future of space-based heatwave forecasting is incredibly promising. New satellite missions with higher resolution sensors and faster data processing capabilities will provide even more detailed insights into temperature trends. These advancements will not only improve prediction accuracy, but also help us better understand the complex interactions between heat waves, climate change, and human activity. By harnessing this knowledge, we can develop more effective strategies to protect lives, infrastructure, and ecosystems from the growing threat of extreme heat. Next, we'll explore how satellites are helping us monitor another critical environmental indicator: glaciers. Stay tuned as we uncover how space-based technology is tracking these icy giants and predicting the disasters they may trigger. Now, let's turn our attention to the icy frontiers of our planet: glaciers. These massive rivers of ice are not just breathtaking natural wonders. They are also critical indicators of climate change and potential sources of catastrophic disasters. Space-based glacier monitoring is set to play a pivotal role in understanding and predicting the risks associated with these frozen giants. Satellites equipped with high-resolution imaging and radar systems are already providing unprecedented insights into glacier movements. By continuously tracking changes in glacier size, thickness, and flow rates, scientists can detect subtle shifts that may signal instability. One of the most significant threats posed by glaciers is the risk of glacial lake outburst floods. These occur when meltwater accumulates in lakes dammed by ice or debris, and the pressure becomes too great, causing a sudden and devastating release of water. Satellites can monitor these lakes, measuring their size and volume, and alerting authorities to potential dangers before disaster strikes. But the applications of space-based glacier monitoring go beyond flood prediction. Glaciers are also sensitive to changes in temperature and precipitation, making them key indicators of broader climate trends. By analyzing satellite data, researchers can track how glaciers are responding to global warming, providing valuable insights into the pace and impact of climate change. This information is crucial for developing strategies to mitigate its effects, from rising sea levels to altered weather patterns. Another critical aspect of glacier monitoring is its role in predicting avalanches and ice collapses. As glaciers retreat or become unstable, large chunks of ice can break off, triggering avalanches or tsunamis in nearby bodies of water. satellites can detect these changes in real time, offering early warnings to communities in vulnerable areas. For example, in regions like the Himalayas or the Andes, where glacial melt poses a significant threat to downstream populations, this technology could save countless lives. Artificial intelligence is also enhancing the capabilities of space-based glacier monitoring. Machine learning algorithms can analyze vast amounts of satellite data, identifying patterns and trends that might be missed by human observers. These algorithms can predict how glaciers will behave under different climate scenarios, helping policymakers and scientists plan for the future. For instance, they can estimate how much sea levels will rise as glaciers melt, enabling coastal cities to prepare for the impact. Looking ahead, advancements in satellite technology promise even greater precision in glacier monitoring. Future missions will feature sensors with higher resolution and faster data transmission, allowing for near instantaneous updates on glacier conditions. This will not only improve our ability to predict disasters, but also deepen our understanding of the complex interactions between glaciers, climate, and ecosystems. As we continue to explore the potential of space-based technology, it's clear that monitoring glaciers from orbit will be essential for safeguarding our planet. By staying one step ahead of these icy threats, we can protect lives, infrastructure, and the delicate balance of our environment. Next, we'll dive into how satellites are helping us predict another pressing issue: coastal erosion. Stay tuned as we uncover the ways space-based systems are keeping our shorelines safe. Now, shifting our focus to the edges of our continents, let's explore how space-based technology is revolutionizing our ability to predict and manage coastal erosion. Rising sea levels driven by climate change are posing an increasing threat to coastal communities worldwide. Satellites are stepping in as a critical tool to monitor these changes and provide early warnings to protect vulnerable shorelines. Using advanced radar and optical imaging systems, satellites can track the gradual wearing away of coastlines with remarkable precision. These systems measure changes in beach width, cliff erosion, and sediment movement, offering a comprehensive view of how coastlines are evolving over time. For example, in areas like the Gulf Coast or the Maldives, where rising sea levels are already causing significant land loss, satellite data is helping scientists and policymakers understand the scale of the problem and plan effective responses. One of the key advantages of space-based coastal erosion monitoring is its ability to provide real-time data on a global scale. Satellites can observe remote or inaccessible areas that are difficult to monitor from the ground, ensuring that no region is left unmonitored. This is particularly important for small island nations and low-lying coastal regions, where even minor changes in sea level can have devastating consequences. By analyzing satellite imagery, researchers can identify patterns of erosion and predict which areas are most at risk, enabling proactive measures such as building seawalls, restoring wetlands, or relocating communities. Artificial intelligence is also playing a growing role in this field. Machine learning algorithms can process vast amounts of satellite data, identifying trends and predicting future erosion with increasing accuracy. For instance, these algorithms can analyze historical erosion patterns and combine them with climate models to forecast how rising sea levels will impact specific coastlines over the next few decades. This predictive capability is invaluable for long-term planning, helping governments and organizations allocate resources effectively and prioritize the most vulnerable areas. Beyond erosion prediction, satellites are also helping us understand the broader environmental impacts of coastal changes. For example, they can monitor how erosion affects marine ecosystems, such as coral reefs and seagrass beds, which are vital for biodiversity and coastal protection. By tracking these changes, scientists can develop strategies to mitigate the damage and preserve these critical habitats. Looking to the future, advancements in satellite technology promise even greater capabilities for coastal erosion monitoring. Next-generation satellites will feature higher-resolution sensors and faster data transmission, allowing for more frequent updates and more detailed analysis. This will enhance our ability to predict erosion events and respond to them in a timely manner, ultimately safeguarding coastal communities and ecosystems. As we continue to face the challenges of climate change, space-based coastal erosion prediction will be an essential tool in our efforts to protect the planet's shorelines. By staying ahead of these changes, we can ensure that coastal communities remain resilient in the face of rising seas. Next, we'll take a closer look at how satellites are tracking another critical environmental issue: pollution. Stay tuned as we uncover the ways space-based systems are helping us monitor and combat pollution on a global scale. Now, turning our attention to the skies above, let's delve into how space-based systems are transforming our ability to track and combat pollution. Pollution, whether in the air we breathe or the water we drink, poses a significant threat to human health and the environment. Satellites are emerging as powerful tools to monitor these pollutants on a global scale, providing critical data that can predict health crises and guide timely interventions. Using advanced sensors and imaging technology, satellites can detect and measure pollutants in the atmosphere and water bodies with incredible precision. For instance, they can identify harmful gases like nitrogen dioxide, sulfur dioxide, and carbon monoxide, which are often released by industrial activities and vehicle emissions. These pollutants contribute to respiratory diseases, cardiovascular problems, and even premature deaths. By continuously monitoring air quality from space, satellites provide real-time data that helps governments and organizations identify pollution hotspots and implement measures to reduce emissions. Water pollution is another area where satellites are making a significant impact. They can detect contaminants such as oil spills, chemical discharges, and algal blooms in oceans, rivers, and lakes. For example, in the aftermath of an oil spill, satellites can track the spread of the spill, assess its environmental impact, and guide cleanup efforts. Similarly, they can monitor harmful algal blooms, which produce toxins that threaten marine life and human health. By providing early warnings, satellites enable authorities to take swift action to protect ecosystems and communities. One of the most remarkable aspects of space-based pollution tracking is its ability to cover vast areas, including remote and hard-to-reach regions. Traditional ground-based monitoring systems are often limited by geography and resources, but satellites offer a comprehensive view of the planet. This global perspective is especially valuable for tracking transboundary pollution, such as smog that drifts across national borders or plastic waste that accumulates in the oceans. By analyzing satellite data, researchers can identify trends and patterns, helping to predict future pollution events and their potential impacts. Artificial intelligence is also enhancing the capabilities of space-based pollution monitoring. Machine learning algorithms can process massive amounts of satellite data, identifying pollution sources and predicting how pollutants will disperse over time. For example, these algorithms can analyze historical pollution data and combine it with weather patterns to forecast air quality in urban areas. This predictive capability allows cities to issue health advisories, adjust traffic policies, or even shut down industrial facilities during periods of high pollution. Beyond tracking pollution, satellites are also helping us understand its broader environmental and health impacts. For instance, they can monitor how air pollution affects crop yields or how water pollution disrupts marine ecosystems. This information is crucial for developing strategies to mitigate the damage and protect vulnerable populations. By integrating satellite data with other sources, such as health records and climate models, scientists can gain a deeper understanding of the complex relationship between pollution and human well-being. Looking ahead, advancements in satellite technology promise even greater precision and efficiency in pollution tracking. Future satellites will feature more sensitive sensors and faster data transmission, enabling more frequent updates and more detailed analysis. This will enhance our ability to predict pollution events and respond to them effectively, ultimately safeguarding public health and the environment. As we continue to grapple with the challenges of pollution, space-based monitoring systems will play an increasingly vital role in our efforts to create a cleaner, healthier planet. By staying ahead of pollution trends, we can take proactive steps to protect both people and ecosystems. Next, we'll explore how satellites are revolutionizing agriculture by predicting crop failures before they happen. Stay tuned as we uncover the ways space-based technology is helping us secure our food supply for the future. Now, shifting our focus from pollution to agriculture, let's explore how space-based technology is revolutionizing the way we monitor and predict crop failures. As global populations grow and climate change intensifies, ensuring food security has never been more critical. Satellites are stepping up to the challenge, offering a bird's-eye view of crop health and enabling us to predict failures before they devastate entire harvests. Using advanced imaging and sensor technology, satellites can monitor vast agricultural areas, tracking the health of crops with remarkable precision. They detect subtle changes in vegetation, such as variations in color, growth patterns, and moisture levels, which can indicate the presence of pests, diseases, or nutrient deficiencies. For example, if a satellite identifies a patch of crops with unusual discoloration, it could signal an infestation of insects or the spread of a plant disease. By catching these issues early, farmers can take targeted action to protect their crops, minimizing losses and preserving yields. Extreme weather events such as droughts, floods, and heat waves are becoming more frequent and severe due to climate change. Satellites play a crucial role in predicting how these events will impact agriculture. By monitoring soil moisture, rainfall patterns, and temperature fluctuations, satellites can provide early warnings of conditions that could lead to crop failure. For instance, if a region experiences prolonged drought, satellites can alert farmers to the risk of water stress, allowing them to implement irrigation strategies or switch to drought-resistant crops. Similarly, during heavy rainfall, satellites can track flooding and help farmers prepare for potential damage. One of the most powerful aspects of space-based crop monitoring is its ability to cover large, remote areas that are difficult to access on the ground. Traditional methods of crop inspection often rely on manual labor and are limited by geography and resources. Satellites, on the other hand, can survey entire countries or even continents in a matter of hours, providing a comprehensive picture of agricultural health. This global perspective is especially valuable for identifying regional trends, such as the spread of a pest or the impact of a heat wave across multiple countries. Artificial intelligence is also enhancing the capabilities of space-based crop monitoring. Machine learning algorithms can analyze vast amounts of satellite data, identifying patterns and predicting future outcomes with incredible accuracy. For example, these algorithms can assess historical crop performance and combine it with weather forecasts to predict the likelihood of a poor harvest. This predictive capability allows governments and organizations to allocate resources more effectively, such as distributing food aid or adjusting trade policies to prevent shortages. Beyond predicting crop failures, satellites are also helping us understand the broader factors that influence agricultural productivity. They can monitor soil health, track deforestation, and even assess the impact of farming practices on the environment. This information is invaluable for developing sustainable agricultural strategies that balance food production with environmental conservation. By integrating satellite data with other sources, such as climate models and economic data, scientists can gain a deeper understanding of the complex challenges facing global agriculture. Looking ahead, advancements in satellite technology promise even greater precision and efficiency in crop monitoring. Future satellites will feature higher resolution sensors and faster data transmission, enabling more frequent updates and more detailed analysis. This will enhance our ability to predict crop failures and respond to them effectively, ultimately safeguarding food security for billions of people. As we continue to face the challenges of a changing climate and a growing population, space-based crop monitoring will play an increasingly vital role in our efforts to ensure a stable food supply. By staying ahead of potential failures, we can take proactive steps to protect crops, support farmers, and secure the future of agriculture. Next, we'll dive into how satellites are helping us tackle urban heat islands and their impact on city populations. Stay tuned as we uncover the ways space-based technology is shaping the future of urban living. Now, let's turn our attention from agriculture to the bustling heart of our cities, where space-based technology is tackling another pressing challenge: urban heat islands. As cities grow and expand, they often become significantly warmer than their surrounding rural areas, creating what's known as urban heat islands. These pockets of intense heat can have serious consequences for both people and infrastructure, but satellites are stepping in to help us monitor and predict their impact with unprecedented precision. Urban heat islands form when natural landscapes are replaced by buildings, roads, and other structures that absorb and retain heat. This phenomenon is exacerbated by factors like limited green spaces, high energy consumption, and the concentration of vehicles. The result: cities can experience temperatures several degrees higher than nearby rural areas, leading to increased energy demands, heat-related illnesses, and even higher mortality rates during heat waves. Satellites equipped with thermal imaging technology are now providing a powerful tool to track these heat islands in real time, offering insights that can help cities adapt and mitigate their effects. By capturing detailed thermal data from space, satellites can map the temperature variations across urban areas, identifying hotspots where heat is most concentrated. This information is invaluable for city planners and policymakers, who can use it to design strategies to cool down these areas. For example, planting more trees, creating green roofs, or using reflective building materials can significantly reduce surface temperatures. Satellites can also monitor the effectiveness of these interventions over time, ensuring that cities are making progress in combating urban heat. But the benefits of space-based urban heat island monitoring go beyond just cooling cities. These satellites can also predict how rising temperatures will impact critical infrastructure. Extreme heat can cause roads to buckle, power grids to overload, and water supplies to dwindle. By analyzing satellite data, engineers can identify vulnerable areas and take preventive measures, such as reinforcing infrastructure or upgrading cooling systems. This proactive approach not only saves money but also protects lives by reducing the risk of heat-related failures. Another key advantage of satellite monitoring is its ability to provide a comprehensive view of entire metropolitan areas. Traditional ground-based sensors are limited in scope and often miss the bigger picture. Satellites, on the other hand, can cover vast regions, capturing data from every neighborhood, street, and building. This holistic perspective allows scientists to study the relationship between urban design and heat retention, offering valuable lessons for future city planning. For instance, they can identify which types of buildings or materials contribute most to heat buildup, guiding the development of more sustainable urban environments. Artificial intelligence is also playing a crucial role in enhancing the capabilities of space-based heat island monitoring. Machine learning algorithms can analyze vast amounts of thermal data, identifying patterns and predicting how heat islands will evolve over time. For example, these algorithms can forecast how a city's heat profile might change with population growth or climate change, helping policymakers prepare for future challenges. This predictive power is especially important as global temperatures continue to rise, making urban heat islands an even greater threat to public health and safety. Looking ahead, advancements in satellite technology promise even greater accuracy and detail in monitoring urban heat islands. Future satellites will feature higher resolution thermal sensors and faster data processing, enabling more precise mapping and real-time updates. This will allow cities to respond more quickly to heat-related risks, whether it's by deploying cooling centers during a heat wave or redesigning neighborhoods to improve airflow and reduce heat retention. As our cities continue to grow and face the challenges of a warming planet, space-based urban heat island monitoring will be an essential tool for creating safer, more sustainable urban environments. By leveraging the power of satellites, we can better understand and address the complex dynamics of urban heat, ensuring that our cities remain livable for generations to come. Next, we'll explore how satellites are helping us predict changes in ocean currents and their impact on global weather patterns. Stay with us as we dive into the fascinating world of space-based ocean monitoring. Now, shifting our focus from the heat of our cities to the vast, dynamic oceans, let's explore how satellites are revolutionizing our understanding of ocean currents and their profound influence on global weather patterns. Ocean currents are like the Earth's circulatory system, transporting heat, nutrients, and even marine life across the planet. These currents play a critical role in regulating climate, but they are also highly sensitive to changes in temperature, salinity, and wind patterns. Satellites are now stepping in to monitor these currents with unprecedented precision, helping us predict how they might shift in the future and what that means for our weather. Satellites equipped with advanced radar and altimeter systems are capable of measuring the height of the ocean's surface with incredible accuracy. Even the slightest variations in surface height can reveal the presence of powerful currents like the Gulf Stream or the Antarctic Circumpolar Current. By tracking these changes over time, satellites can provide real-time data on the speed, direction, and strength of ocean currents. This information is crucial for understanding how heat is distributed across the planet, as warm currents can raise temperatures in certain regions while cold currents can have a cooling effect. One of the most significant applications of space-based ocean current monitoring is its ability to predict changes in global weather patterns. For example, the El Niño and La Niña phenomena, which are driven by shifts in ocean temperatures and currents, have far-reaching impacts on weather systems worldwide. Satellites can detect the early signs of these events by monitoring changes in sea surface temperatures and current patterns. This allows meteorologists to issue more accurate forecasts, giving communities time to prepare for extreme weather events like droughts, floods, or hurricanes. But the benefits of space-based ocean current prediction go beyond just weather forecasting. These satellites also play a vital role in understanding long-term climate trends. As global temperatures rise, ocean currents are expected to undergo significant changes, which could disrupt ecosystems, alter marine habitats, and even affect the global carbon cycle. By continuously monitoring these currents, satellites provide scientists with the data they need to model future scenarios and assess the potential impacts of climate change. This knowledge is essential for developing strategies to mitigate the effects of a warming planet. Another exciting aspect of this technology is its ability to support maritime industries. Shipping companies, for instance, rely on accurate information about ocean currents to optimize routes, reduce fuel consumption, and avoid hazardous conditions. Satellites can provide real-time updates on current patterns, helping ships navigate more efficiently and safely. Similarly, the fishing industry can use this data to locate productive fishing grounds, ensuring sustainable practices and protecting marine biodiversity. Artificial intelligence is also enhancing the capabilities of space-based ocean current monitoring. Machine learning algorithms can analyze vast amounts of satellite data, identifying patterns and predicting how currents might change in response to various factors, such as melting ice caps or shifting wind patterns. These predictions are invaluable for policymakers, who can use them to make informed decisions about coastal management, disaster preparedness, and climate adaptation. Looking ahead, advancements in satellite technology promise even greater accuracy and detail in monitoring ocean currents. Future satellites will feature higher resolution sensors and faster data processing, enabling more precise tracking and real-time updates. This will allow scientists to detect subtle changes in current patterns that could signal larger shifts in global climate systems. By staying ahead of these changes, we can better prepare for the challenges of a rapidly changing world. As we continue to explore the mysteries of our oceans, space-based ocean current prediction will be an indispensable tool for understanding and adapting to the complex interplay between the seas and the skies. By harnessing the power of satellites, we can unlock new insights into the forces that shape our planet's climate, ensuring a safer and more sustainable future for all. Next, we'll delve into how satellites are helping us predict geomagnetic storms and their potential impact on navigation systems. Stay tuned as we uncover the next frontier in space-based disaster prediction. Now, let's turn our attention from the swirling currents of the oceans to the invisible forces that shape our planet's magnetic environment. Geomagnetic storms, though unseen, have the power to disrupt navigation systems, communication networks, and even power grids. These storms are caused by disturbances in Earth's magnetic field, often triggered by solar activity like solar flares or coronal mass ejections. Satellites are now playing a critical role in monitoring these magnetic changes, giving us the ability to predict geomagnetic storms before they strike. Satellites equipped with magnetometers and other advanced instruments are capable of measuring the strength and direction of Earth's magnetic field in real time. These measurements are essential for detecting anomalies that could signal an incoming geomagnetic storm. By continuously monitoring the magnetic field, satellites can provide early warnings, allowing governments and industries to take precautionary measures. For example, airlines can reroute flights to avoid areas where navigation systems might be compromised, and power grid operators can implement safeguards to prevent widespread blackouts. One of the most significant challenges in predicting geomagnetic storms is understanding the complex interactions between the Sun and Earth's magnetic field. Solar activity, such as bursts of charged particles, can travel through space and interact with our planet's magnetosphere, creating disturbances that ripple across the globe. Satellites positioned in strategic orbits, such as those in the Lagrange points, provide a unique vantage point to observe these interactions. They can track the flow of solar wind and measure its impact on Earth's magnetic field, offering valuable data for forecasting geomagnetic storms. The implications of accurate geomagnetic storm prediction are far-reaching. Navigation systems, particularly those relying on global positioning system technology, are highly sensitive to magnetic disturbances. During a geomagnetic storm, the accuracy of these systems can degrade, posing risks for aviation, maritime navigation, and even everyday activities like driving. By providing early warnings, satellites help mitigate these risks, ensuring the reliability of navigation systems even in the face of solar activity. Beyond navigation, geomagnetic storms can also affect communication networks. High-frequency radio signals used in aviation and emergency services can be disrupted by magnetic disturbances. Satellites monitoring the magnetic field can alert operators to potential disruptions, allowing them to switch to alternative communication methods or adjust frequencies to maintain connectivity. This is especially critical during emergencies, where reliable communication can mean the difference between life and death. Power grids are another area vulnerable to geomagnetic storms. When intense magnetic disturbances interact with Earth's surface, they can induce electric currents in power lines, potentially damaging transformers and causing widespread outages. Satellites provide the data needed to predict these events, enabling power grid operators to implement protective measures, such as reducing load or isolating vulnerable components. This proactive approach can prevent catastrophic failures and ensure the stability of energy supplies. artificial intelligence is also enhancing our ability to predict geomagnetic storms. Machine learning algorithms can analyze vast amounts of satellite data, identifying patterns and correlations that might be missed by traditional methods. These algorithms can predict the likelihood and intensity of geomagnetic storms, providing more accurate and timely forecasts. This is particularly important as solar activity increases during periods of heightened solar activity, known as solar maximums. Looking ahead, advancements in satellite technology promise even greater precision in geomagnetic storm prediction. Future satellites will feature more sensitive instruments and faster data processing capabilities, allowing for real-time monitoring and analysis. This will enable scientists to detect subtle changes in Earth's magnetic field that could signal the onset of a geomagnetic storm, giving us more time to prepare and respond. By harnessing the power of satellites, we are gaining unprecedented insights into the forces that shape our planet's magnetic environment. This knowledge not only helps us predict and mitigate the effects of geomagnetic storms, but also deepens our understanding of the intricate relationship between the Sun and Earth. As we continue to explore this frontier, space-based geomagnetic storm prediction will be an essential tool for safeguarding our technology and infrastructure in an increasingly interconnected world. Next, we'll explore how satellites are tracking iceberg movements to predict potential hazards for shipping routes. Stay tuned as we uncover the next chapter in space-based disaster prediction. Now, shifting our focus from the invisible forces of geomagnetic storms to the tangible dangers of the open seas, let's dive into how satellites are revolutionizing iceberg tracking. Icebergs, massive chunks of ice that break off from glaciers or ice shelves, pose significant risks to shipping routes, especially in regions like the North Atlantic. These floating hazards can damage ships, disrupt maritime trade, and even lead to environmental disasters if they collide with oil tankers or other vessels. Fortunately, space-based technology is stepping in to provide a solution. Satellites equipped with high-resolution imaging and radar systems are now capable of monitoring icebergs with incredible precision. By capturing detailed images of the ocean surface, these satellites can detect the size, shape, and movement of icebergs in real time. This data is then analyzed to predict their trajectories, giving shipping companies the information they need to avoid collisions. For example, if a satellite detects a large iceberg drifting toward a busy shipping lane, it can alert vessels in the area to reroute, preventing potential disasters. One of the key challenges in iceberg tracking is the dynamic nature of ocean currents and weather conditions, which can cause icebergs to change direction unexpectedly. Satellites overcome this challenge by continuously monitoring these factors, providing up-to-date information on how icebergs are likely to move. Advanced algorithms process this data, factoring in variables like wind speed, wave height, and ocean temperature to generate accurate predictions. This level of detail is crucial for ensuring the safety of ships navigating icy waters. The benefits of space-based iceberg tracking extend beyond just avoiding collisions. By predicting where icebergs will drift, satellites also help protect marine ecosystems. Icebergs can carry sediment and nutrients that affect ocean life, and their movements can influence the distribution of marine species. Understanding these patterns allows scientists to study the ecological impact of icebergs and develop strategies to mitigate any negative effects. For the shipping industry, the ability to predict iceberg movements is a game changer. It reduces the risk of costly accidents, minimizes delays caused by rerouting, and enhances overall operational efficiency. In regions like the Arctic, where melting ice is opening new shipping routes, this technology is becoming increasingly important. As more vessels navigate these waters, the demand for accurate iceberg tracking will only grow. Looking ahead, advancements in satellite technology promise even greater capabilities for iceberg monitoring. Future satellites will feature enhanced sensors and faster data processing, allowing for more frequent updates and higher resolution images. This will enable even more precise tracking of icebergs, ensuring that shipping routes remain safe and efficient. Additionally, the integration of artificial intelligence will further improve prediction accuracy, making it possible to anticipate iceberg movements with unprecedented reliability. By harnessing the power of satellites, we are not only safeguarding ships and their crews, but also protecting the delicate balance of our oceans. Space-based iceberg tracking is a prime example of how technology can address real-world challenges, turning potential hazards into manageable risks. As we continue to explore the frontiers of space-based disaster prediction, this innovation will play a vital role in ensuring the safety and sustainability of global maritime trade. Next, we'll uncover how satellites are detecting subsurface water reserves to predict droughts and support sustainable water management. Stay tuned as we continue our journey into the future of space-based disaster prediction. Now, let's turn our attention from the icy dangers of the open seas to the hidden treasures beneath our feet. Satellites are not just revolutionizing how we track icebergs, they're also transforming how we detect and manage one of Earth's most vital resources, water. Specifically, space-based subsurface water detection is emerging as a groundbreaking tool for predicting droughts and ensuring sustainable water management. Imagine being able to see beneath the Earth's surface, mapping out vast reservoirs of water hidden deep underground. This is exactly what satellites equipped with advanced radar and imaging technologies are now capable of. By sending signals that penetrate the ground and bounce back, these satellites can create detailed maps of subsurface water reserves. This data is invaluable for regions facing water scarcity, as it helps identify areas where groundwater can be accessed sustainably. One of the most significant applications of this technology is in drought prediction. By monitoring changes in subsurface water levels over time, satellites can provide early warnings of impending droughts. For instance, if a satellite detects a steady decline in groundwater reserves in a particular region, it can alert authorities to take proactive measures, such as implementing water conservation programs or exploring alternative water sources. This early intervention can prevent the devastating impacts of droughts such as crop failures, water shortages, and economic instability, but the benefits don't stop there. Space-based subsurface water detection also plays a crucial role in sustainable water management. By providing accurate data on groundwater availability, satellites help governments and organizations make informed decisions about water usage. For example, farmers can use this information to optimize irrigation practices, ensuring that crops receive the right amount of water without depleting local reserves. Similarly, urban planners can design water systems that balance the needs of growing populations with the preservation of natural resources. The technology behind this innovation is truly remarkable. Satellites use a combination of radar, thermal imaging, and gravitational measurements to detect variations in subsurface water. These measurements are then analyzed using sophisticated algorithms to create detailed models of groundwater distribution. This level of precision allows scientists to predict how water reserves will change over time, taking into account factors like rainfall, evaporation, and human consumption. Looking ahead, the potential for space-based subsurface water detection is immense. Future satellites will feature even more advanced sensors, capable of detecting smaller changes in water levels and providing more frequent updates. This will enable more accurate predictions and better informed decision-making. Additionally, the integration of artificial intelligence will enhance the ability to analyze complex data sets, making it possible to predict droughts and manage water resources with unprecedented accuracy. By harnessing the power of satellites, we are not only addressing the immediate challenges of water scarcity, but also laying the groundwork for a more sustainable future. Space-based subsurface water detection is a testament to how technology can transform our understanding of the natural world and help us manage its resources more effectively. As we continue to explore the frontiers of space-based disaster prediction, this innovation will play a vital role in ensuring the resilience and sustainability of communities around the globe. Next, we'll delve into how satellites are coordinating disaster response efforts, providing real-time data to emergency teams and improving rescue operations. Stay tuned as we uncover the final piece of this futuristic puzzle. Now, shifting our focus to the final frontier of space-based disaster prediction, let's explore how satellites are not just tools for forecasting, but also vital players in coordinating disaster response efforts. Picture this: a massive earthquake strikes a densely populated city, or a hurricane devastates a coastal region. In these critical moments, every second counts, and the ability to coordinate rescue operations efficiently can mean the difference between life and death. This is where space-based disaster response coordination steps in, revolutionizing how we manage emergencies. Satellites equipped with high-resolution cameras, thermal imaging, and communication systems are transforming the way disaster response teams operate. By providing real-time data from above, these satellites offer a bird's-eye view of the affected areas, allowing emergency teams to assess the situation quickly and accurately. For example, after a natural disaster, satellites can map out damaged infrastructure, identify blocked roads, and locate areas where survivors might be trapped. This information is relayed to ground teams, enabling them to prioritize their efforts and allocate resources where they are needed most. One of the most groundbreaking aspects of this technology is its ability to enhance communication during disasters. When terrestrial communication networks are down due to damaged infrastructure, satellites can step in to provide a reliable link between emergency responders, government agencies, and humanitarian organizations. This ensures that critical information, such as evacuation routes or the location of medical supplies, can be shared instantly, even in the most remote or devastated areas. But the role of satellites doesn't end there. They also play a crucial part in coordinating international disaster response efforts. In the aftermath of a major disaster, multiple countries and organizations often come together to provide aid. Satellites help streamline this process by offering a unified platform for sharing data and coordinating logistics. For instance, they can track the movement of relief supplies, monitor the deployment of rescue teams, and even predict where additional resources might be needed based on real-time updates. The integration of artificial intelligence further amplifies the capabilities of space-based disaster response coordination. AI algorithms can analyze satellite data to identify patterns and predict how a disaster might evolve. For example, if a flood is spreading, AI can forecast which areas are likely to be affected next, allowing responders to act proactively. Similarly, AI can help optimize the deployment of resources by analyzing factors like population density, terrain, and the severity of damage. Looking to the future, the potential for space-based disaster response coordination is limitless. Advances in satellite technology will enable even faster data transmission, higher resolution imaging, and more precise tracking of disaster impacts. Additionally, the development of satellite constellations, networks of interconnected satellites, will ensure continuous coverage, even in the most challenging conditions. This means that no matter where a disaster strikes, satellites will be there to provide the critical support needed to save lives and rebuild communities. As we wrap up our exploration of space-based disaster prediction, it's clear that these technologies are not just about foreseeing the future, they're about shaping it. By harnessing the power of satellites, we are creating a world where disasters are met with swift, coordinated, and effective responses. This final prediction underscores the transformative potential of space-based technologies, offering hope for a safer and more resilient future. Stay tuned as we bring all these predictions together in our concluding thoughts. reflecting on how these innovations will redefine our relationship with the planet and the cosmos. As we bring our journey through these 30 futuristic predictions to a close, it's impossible not to marvel at the transformative potential of space-based disaster prediction technologies. From artificial intelligence-powered satellite networks to quantum computing for disaster modeling, these innovations are reshaping how we anticipate and respond to natural and cosmic threats. Each prediction we've explored, whether it's real-time flood monitoring, asteroid impact detection, or global wildfire tracking, paints a vivid picture of a future where humanity is no longer at the mercy of disasters, but instead empowered to act with foresight and precision. These advancements are not just about technology, they're about saving lives, protecting communities, and safeguarding our planet. Imagine a world where earthquakes no longer catch us off guard, where hurricanes are tracked with pinpoint accuracy, and where even the most remote regions have access to early warnings and coordinated disaster response. This is the future that space-based technologies are building, a future where resilience is not just a goal but a reality. But this future doesn't happen on its own. It requires continued innovation, investment, and support for space exploration initiatives. By staying informed about these advancements and advocating for their development, we can all play a part in shaping a safer, more secure world. So, if you're as excited about the possibilities as we are, don't forget to hit that like button, subscribe to our channel, and ring the notification bell to stay updated on the latest breakthroughs in space technology and beyond. Together, let's embrace the future and ensure that humanity is ready for whatever challenges and opportunities lie ahead.